All right, welcome to this explainer. Today, we're literally going right under the hood of Boston Dynamics' famous Atlas robot to see exactly how it's making the massive leap from those viral internet videos straight onto the factory floor. Now, if you follow robotics, you already know Atlas. But what we're about to unpack today isn't just another cool tech demo. No, it's a fundamental shift in how humanoids operate, and it's absolutely going to change the way we think about industrial labor.
Okay, let's dive into this. A recent report by analyst Kang Sung Jin over at Kibi Securities highlights, quote, major advances in the development of humanoid robot general intelligence. Now that phrase right there, general intelligence, that's the key to this whole shebang. We're not just talking about some pre-programmed machine looping the exact same movement over and over anymore, right? We're talking about a machine that is genuinely capable of adapting to unfamiliar, totally chaotic industrial environments in real time, all without relying on strict step-by-step instructions. Which brings us to a fascinating, almost mind-bending question. How exactly does a machine train for millions of hours in a single day? Just kind of keep that in your head as we go. Because to understand Atlas's incredible leap forward, we really need to take a journey into both the software and the hardware that makes this seemingly impossible math a reality.
Let's start with Section 1, the software layer, Atlas's accelerated mind. So this is where the magic really begins, way before the robot even takes a single physical step. The absolutely crucial number here is millions. Boston Dynamics has built this incredibly accelerated training framework where they can run simulations that are equivalent to millions of hours of robot training, all in a single massive daily compute cycle. It's basically out there learning, failing, and adapting in a highly accurate virtual world at a scale and speed that's honestly hard for the human mind to even wrap around. But here is the real kicker, dropping all the way down to just 1 hour. That is literally all it takes to transfer those newly simulated behaviors and skills into the actual physical Atlas robot. Just think about that for a second. Millions of hours of digital trial and error completely distilled and downloaded into a physical machine in the time it takes you to go grab a coffee and check your emails. The development cycle has just been radically, permanently shortened.
And this brilliantly illustrates how Boston Dynamics isn't just pulling this off in a vacuum. They've strategically divided the labor through these massive partnerships. You've got Google DeepMind bringing the heavy-hitting artificial intelligence expertise and advanced learning systems to the table. And meanwhile, Nvidia is stepping up to supply the high-performance computing infrastructure you actually need to run those massive-scale simulations. It's literally the ultimate dream team of AI mind and computing muscle.
Moving right along to Section 2, the hardware layer, streamlining the body. Now, obviously, a brilliant virtual mind needs an equally capable physical vessel to be of any real use to us. And to understand how they built that vessel, we first need to introduce the villain of our story, the sim-to-real gap. This is a notorious challenge in robotics. It's basically where skills that work perfectly in a pristine, flawless computer simulation suddenly fail, sometimes comically, sometimes pretty dangerously, when you try to transfer them to the messy physical world. Overcoming this gap, well, that was the primary goal of Atlas's recent physical redesign. So, how did they actually defeat the sim-to-real gap? Well, first, they streamlined the entire system down to just 2 actuator types across the whole body. Second, they designed the arms and legs to be perfectly symmetrical. And third, they completely eliminated all external cables. By aggressively simplifying the physical architecture like this, they made the robot incredibly easy to accurately simulate in that virtual environment we were just talking about. But getting rid of those external cables didn't just help with the computer simulation side of things. It actually allows for continuous joint rotation with greatly reduced wear and maintenance. Atlas literally has no cords to get tangled or snap. This gives the robot just unbelievable flexibility to perform continuous movements that are downright impossible for conventional humanoids, all while surviving the harsh, repetitive grind of a real industrial setting. All right, let's see this in practice in Section 3, Physical Intelligence in Action. Okay, so we've got the accelerated software mind, and we've got the streamlined hardware body. Let's see what happens when those two collide in the real world. Now, what's really interesting about this slide is the massive gap between what Atlas trained for and what it actually achieved on the floor. In simulation, the training load was maxed out between 50 to 70 pounds. But in actual physical testing, Atlas successfully picked up and moved an automotive shock absorber, which is basically the size and weight of a heavy-duty refrigerator, weighing well over 100 pounds. It didn't just memorize how to lift a specific weight, its general intelligence kicked in and allowed it to instantly adapt to an unexpectedly heavier object. Because as you can imagine, lifting a massive object like that isn't just a matter of having really strong robotic arms or simple visual perception. It requires full body coordination, it requires anticipating the shifting weight of the object, maintaining dynamic balance, and executing incredibly precise force control. Atlas has to use its entire body as a counterweight, just constantly adjusting its footing and posture in real time. This proves Atlas possesses true, functional physical intelligence. And this actually brings us to a huge misconception we really need to clear up. I mean, the public loves those viral videos of Atlas doing backflips, parkour, handstands, we've all seen them. But from an engineering view, those athletic feats aren't just for internet cloud, they are actually rigorous tests for practical endurance. By pushing the robot to its absolute limits with gymnastics, engineers are actually developing the real-time slip recovery, agility, and balance that's absolutely crucial for safely navigating unpredictable, hazard-filled factory floors. Finally, let's zoom out in Section 4, the market reality, future projections. So the underlying technology is phenomenal, for sure. But what does this actually mean for the business of building things? Let's look at the macroeconomic impact. First off, Boston Dynamics isn't just some experimental research lab anymore. They now have the massive backing of Hyundai Motor Group. This completely cements their commitment to industrial humanoid robotics. With the manufacturing muscle of a major global automaker standing right behind them, Boston Dynamics is positioned squarely as a leading commercial contender in an emerging and highly competitive market. So, the crucial point is what analysts are predicting based on all this immense momentum. According to that KB Securities report, by 2035, Boston Dynamics is projected to capture a staggering 60% share of the premium industrial humanoid segment. I mean, that is absolute market dominance in the making for these heavy-duty, highly intelligent factory robots. And even when you zoom out to look at the entire global humanoid robot market, which, by the way, includes everything from simple retail delivery bots all the way down to basic consumer models, they're still projected to secure a highly lucrative 15% overall share. The financial implications of bridging that sim-to-real gap we talked about, they are simply staggering. Which leaves us with this final, genuinely profound question. When humanoids like Atlas fully achieve general intelligence, what does the factory of the future actually look like? If a machine can learn millions of hours of skills overnight, adapt its physical body to unpredictable heavy labor the very next day, and completely dominate the industrial market, what exactly is the future of human labor? It's a fascinating, highly disruptive shift, and it's happening much, much faster than anyone anticipated. Thank you so much for joining me for this explainer today. Keep learning, and I'll catch you next time.